Hey, we're going to be talking about the intermediate value theorem, also known as the IVT. First thing we're going to do, let's see, we got to verify the intermediate value theorem and find the value of C. So this is going to be our first one here. And then I think we're going to do this one next. Alright, first thing we're going to do is go ahead and state the theorem of the intermediate value theorem, also known as IVT. If f is continuous on, we've got a closed interval a, b, and k is any number between f of a and f of b, then there's at least one number c in this interval such that f of c is equal to k. So if we look at an example, that should clear all this up, right? But we've got to state these theorems first. Okay, so here's our function, nice polynomial. Here's our closed interval, we're between 0 and 5, and we're going to let k equal 11. So we're going to have to find a c. Let's take a look at the graph. So here's the graph of our polynomial function, okay? And we're on the interval between 0 and 5, so we're just concerned about between here and 5, alright? And what I'm going to do is find f of 5, which that's where this point is, and then f of 0, and that's this point here, and 11, k is 11, that's going to be the number between, right, we're on the y-axis here, between this point here on the y-axis, and if we follow this point straight across here, right, so k is in this interval, right, and then we're saying that there's got to be a c somewhere down here, so that f of c is equal to 11. What? Anyway, let's work it out. Okay, so I did both my endpoints, -1, 29, so we know 11 is between -1 and 29. And then f of c, just plugging c in for x here, so all of this, f of c, is equal to 11. Okay, and so if f of c is equal to 11, then we would set, right, this equal to 11, and then we just simply solve for c. That's all we got to do. And I just factored it. And we get c is equal to -4, c is equal to 3. Now, we're going to choose c is equal to 3 because 3 is in our interval between 0 and 5. So there it is. Right, so c is equal to 3 right here. Alright, let's look at another example. We've got x cubed minus x squared plus x minus 2. Here's our closed interval. We're going to let k equal 4 this time. So between this point here on the y-axis, following this straight across, right? So 4 is somewhere in here. Then there must be a number down here on the x-axis. So then we plug it in, we get 4 out. That's all I'm basically saying. Alright, so we go ahead, just plug both our endpoints in. We know that 4 is in between here. We want to make sure. Plug c in, right? Now this has to be equal to, f of c must be equal to 4, so we set both these equal to each other and then solve for c. Now this is not something really nice where we can just factor it. I used the rational zero test. And the rational zero test is you just take the coefficient in front of c, which is 1, and then you look at all the factors of 6, which is 1 goes into 6, 2 goes into 6, and 3 goes into 6, and then it's plus or minus. And then you look at all their combinations. So 1 over 1, this 1 is this one right here, and that 1 goes down here. And right, 2 over 1, 3 over 1, right, they're all plus or minus. And then you look at all of these, and whichever one makes the 0, that's going to be the winner, right? And it happens to be 2, so if you plug 2 in, you end up getting 0 out. And what I did here is I actually graphed this function. As you can see, it crosses here at 2. Alright, so here's our graph, and here's 2, and there's the point.